Hello everyone and welcome to our new section which is called Trie. Till now we have learned different types of trees such as binary tree, binary search tree, AVL tree and binary heap. Now in this section we will learn another type of tree which is called Trie. In this section you will get a deep knowledge about Trie data structure, which includes creation of Trie, common operations such as insert, delete, search on Trie. In the first lecture let's see what's a Trie and why we need it. So let's get started. So a trie is a tree-based data structure that organizes information in a hierarchy. While most of other data structures are designed to manipulate generic data, trie is often used with strings. It's used for storing words in a way that which enables for fast lookups. Since trie stores characters at each node, it's very efficient for prefix matching in the English language. So let's look at the properties of trie. So the first property is it's typically used to store or search strings in a space and time efficient way. And the second property is any node in a trie can store non-repetitive multiple characters. And the third property is that every node stores link of next character of string. And finally, the last property is that every node keeps track of end of string. So let's look at them one by one. Basically, when we work with strings, our main goal is to make the search operation as efficient as possible. So in this case, the ideal data structure is the trie data structure. Now a typical trie looks like this. So if you look at this trie over here, we can see that each node has multiple children. It can have 2 or 3 children. So in case of I, we see that for I we have 1 children, for AIM we have 3 children over here. So in this case, we don't have any limit for the number of children in any node in case of trie. And also we can see that in each node of trie, we can store 1, 2, or 3 or any number of characters. So from this picture over here, we can see that in the root node we have 2 characters, then in the left child we have 1 character, then in the right child we have 3 characters. So this means that we can store any number of characters in any node in this case. So this is the second property of trie, in which we say that any node can store non-repetitive multiple characters. Now here you need to be careful that when we say non-repetitive characters, you might be interested why non-repetitive characters. So we will explain this in a while, just bear with me about this. So also from this tree we can see that every node stores the reference to the next node. So if you look at this node over here carefully, we can see that from I to RT we have a reference, and from AB to I we have another reference, and from AB to AIM we have another reference. So from each node we have reference to the next node. So this is the third property of trie, in which it says that every node stores a link of next character of the string. And finally, the last property says that every node keeps a track of end of string. So if you look at this trie structure over here, you can easily see that at the end, these nodes over here denotes the end of string over here. So from this tree, we can easily see that we have stored AIR string over here. So if you look at this trie over here, you can see that the first character is A, then in the left child we have I, then in the left child we have R. Then at the end, we have pointed dot over here, which means that this is end of string. So this means that we have AIR over here. Now the second word is AIT. So from here you can see that AIT, and after T we have put it over here dot. So this means that this is end of string. Now the next word is bar. So here you can see that in the root we have B, then we have A in the right child, then we have R over here. So after R we have put a dot over here, which points to the end of string. So similarly it continues for the next string. So in the next string we have Bill. So we can easily see that BIL. So we have end of string over here. And the last word is BM. So here you can see that BM, then at the end we have end of string over here. Now we have 5 strings stored in this trie over here. Now let's see how can we store these strings over here on a very high level. So let's say we have a word air, so which consists of 3 letters. So this means that we need to create 3 nodes over here. Now the first letter is A. So what we are going to do is we are going to create a new node. Then we are going to assign A to this new node over here. Now after assigning, we are going to continue to the next characters. So the next character is I. So this means that we have to create a node, then assign I to this node over here. Then we are going to create a link between A to I. Now after doing so, we are going to continue to the next node. In the next node, we should have the letter of R because as we said in case of trie data structure, we are storing each letter in one node. That's why we have to create a new node over here and assign R to it. Now after doing so, we see that we have reached the end of the string over here. So this means that we have to mention that this is end of string over here. Now whenever we are mentioning the end of string, we are creating a new node and setting the end of string character to true in this case. Because in this case, if we see a node with the end of string property to true, in this case, it means that the parent of this node over here is end of string. So this means that we have AIR over here like this. So AIR is a string in this case. Now let's continue to the next word. So in the next word, we have AIT. So here, this is an interesting point because in this case, we are going to check that if we have A over here, we are not going to create a new node for A, we are going to use the same node over here. So in this case, we are checking that in our root node we have A, so this means that we are not going to create any node for A, we are going to use the same node. Then we are going to continue to the second node. In the second node we have I, and our second character over here is I. So this means that we can use same character over here. Now the third character in this case, in this triad data structure is R, but in our letter is T. So this means that we need to create a new node for T and assign T to this new node over here. But as we said before, in one node we can store multiple characters. So this means that we can store these two into this node over here in which we have R. So I'm going to put T over here. Now after doing so, we have to denote that this is the end of string. So I'm going to create a new node for this T over here and create a link from T to this new node and denote that this is end of string. Now let's continue to the next word. So the next word will be BAR. So in this case, one more time, we are going to check that if the first letter of this string over here matches with the root node of this triad structure. So in this case, you see that it's not matching. So this means that I can insert B to this triad structure over here with the root node. So in the root node we have A, so I'm going to add one more letter to this root node. It's going to be AB. Then we are going to continue to the next node. So in the next node we see that we have I, so which is not matching with the second letter of this string over here. So this means that we need to create a new node and assign A to it. So after creating, we are going to create a link between B to this new node over here. Now after creating this A over here, we see that we don't have next node over here. So this means that for R, we need to create a new node and assign R to it. Now after doing so, we have reached the end of string. So this means that we need to denote that this is end of string. So after doing so, we have denoted that this is end of string. So here we can easily see that we have a string which is bar. Now the next letter is Bill. So one more time, we are going to check that if in a root node we have a character of B. So here we can see that we have a character of B, but the next character is I. So we are going to check that after B we have I or not. So here we can see that after B we have A, so we don't have I. So this means that we are going to insert I over here into the second node. Now after inserting it, we can continue to the next node. So in the next node we have R. So this means that for I we don't have next node, so we are going to create a new node and assign L to it. Then after doing so, we are going to create end of string over here, because in this case we have Bill as a string over here. If you don't set end of string, it's not going to recognize Bill as a string over here. Now in our case, the next string is BM. So this means that one more time we are going to check that for B, if we have B in the root node or not. So we see that we have. So then we are going to continue to the next character. So in the next node we have A and I. So this means that we can insert M over here. So if I insert M over here, and we need to denote that this is end of string, so I'm going to create a new child for M over here, and I'm going to set it as a end of string over here. So with this, we have successfully inserted these characters to this triad structure over here. So that's how we are storing characters in a triad data structure. So hopefully with this, everything is clear about what is a triad data structure. Now let's continue to see why we need to learn a triad data structure. So in the world of computer science, there are many problems that can be solved using easily triad data structure. For instance, spelling checker or autocomplete of strings feature are done by using triad data structure. Now when you go to the Google and search for any word, you can see that Google suggests you when you start to type any letter. You might be interested how Google predicts the next letter. So one way of doing this is using triad data structure. So these suggestions comes from the triad data structure. So simply when you type A, so whatever the next node is there, we return all of them as a suggestion. In that way, we simply implement a Google autocomplete feature. Now, of course, Google might be using some more advanced technology, but the logic behind remains same. Now, finally, one more thing to note over here is that the nodes that we are seeing over here are very simplistic. In actual world, this is how a typical node will look like. So it will have characters and link to the trie node, which is linked to the its children. So it also have a property of end of string. So here you can see that in some characters we are going to set end of string yes, in some characters we are going to set end of string no. So with this we have come to the end of this lecture. So hopefully everything is clear about what is a trie data structure and why we need it. Now in the next lecture, let's see common operations on trie data structure.